Okay, so we've got a few examples of inequalities that we're going to solve in graph. And then we've got a compound inequality at the very end. So we're going to take a look at all of these here, and it should be very quickly. It should move really quickly. So inequalities are very basic, okay? Think about it this way. I call inequalities, like I call them equations, but they are not equals. So they are not equations, in other words, because unequal, not equal. So let's take a look at the first one. All right, now here's the rule of thumb. The rule of thumb that I subscribe to is that we always want the variable on the left and we want any constants on the right. So that's the rule of thumb. Okay, so we're going to try to move all variables this way, all constants to the right. So I've got plus 4x here and plus 4x there. And then what I'm going to do is I'm going to cancel this right there. And here I end up with x minus 2 greater than 10. All right. And so now I'm going to add 2 to the other side. And I have that right there. And I end up with x greater than 12. So I have my answer there. Now to sketch this on a number line, it's really not important how we sketch the number line so much as that somewhere on the number line we mark 12. So there's my 12. I can put on here negative infinity. I can put on here positive infinity. But notice that x is greater than 12. So what I'm going to do is I'm going to say, okay, x is greater than 12. Well, in this case, it's not greater than or equal to, so this is kind of not including 12. So when we're not including, we use a parentheses like this. And notice the arrowhead here. Which way is it telling us to shade? Well, it's pointing this way, to the right. So we're going to shade to the right. Okay? We're going to shade to the right, just like this. Now, if you notice here, this graph that we sketched helps us write out our answer in what's called interval notation. So here it is. We're going to go from 12 with the parentheses all the way to infinity. And infinity is not a point, it is rather a destination, so that's why we put a parentheses there. So this is the interval notation answer, all right? And this is using the inequality symbols. All right, but interval notation is usually what we're concerned with. So let's take a look at this one, and I'll try to do it all in one step. We've got negative 6x here, a negative 6x here, and I'm going to move the 9 to the other side, so that's what I mean by doing it all in one step. Okay, and let's see what cancels here. Well, the 6x cancels there, the 9 cancels there. This leaves me with a negative x greater than or equal to 17 minus 9 is, you guessed it, 8. And now the last step is to isolate x by dividing by the coefficient that's in front. In this case, it's negative 1. So we're going to divide both sides by negative 1. But wait, whenever you divide in an inequality by a negative number, you actually have to flip the inequality sign. So what the answer is here is that x is now less than or equal to negative 8. Okay, so now let's sketch our number line. Let's just place negative 8 somewhere like right here. We can put our negative infinity there. We can put our positive infinity there. All right, so x is less than or equal to negative 8, so which way should we go? Well, in this case, to the left. So what we're going to do, because it's less than or equal to, we actually need to put a square bracket. All right, so there's my square bracket, and I am going to highlight this way to the left of the negative 8. And if I'm talking about interval notation once more, I'm going to end up writing, well, parentheses for the infinity, so negative infinity, parentheses to negative 8 with a square bracket, just like this one right here. So this would be the interval notation answer for this inequality right here. Okay, and now what we're going to do is we're going to combine everything that we've learned in these two examples and work on a compound inequality. But as you'll see, it's actually quite simple. So here we have negative 4 is less than negative 2x plus 4, which is less than or equal to 4. The other way that you might see it is they might say, well, negative 2x plus 4 is greater than negative 4, but it is less than or equal to 4. Doesn't matter the way you say it. The way that you work it out is the same though. What you want to do is you want to isolate the variable in the middle and move everything else to the outsides. And what you do to one side, you do to one side, and you do to the other side. Very good. So we're going to do it kind of all at once. So first things first, let's subtract 4 from all sides. So here I am subtracting 4. This right here is going to cancel, and it's going to give me here on the left negative 8. In the middle I've got less than negative 2x, and then less than or equal to, and 4 minus 4 of course is 0. Now the very last step is to divide everything by negative 2. So I'm going to divide by negative 2. But remember that whenever you divide by a negative number, you have to flip the inequality sign. So that's exactly what I'm going to do. This is now going to become greater than or equal to. This right here is going to give me positive 4, and this right here is going to give me 0, and this right here is going to give me x. So now we kind of have to look at this in a mirror, because we actually have to read it the other way around. So that's exactly what I'm going to do, is I'm going to read it backwards. 0 then is less than or equal to x, and x is less than 4. So there is my less than 4, and this is what it would look like using this kind of inequality notation. So now let's graph this. So I'm going to put, of course, 0. I'm going to put 4. The infinities are not necessary because, as you might be able to tell, the answer for x lies somewhere in between 0 and 4. So on 0 we need a square bracket, and on 4 we actually need a parentheses. So we're actually going to highlight the region in between 0 and 4. And in terms of our interval notation, the answer looks something like this. Okay, so that right there is how we would solve two regular inequalities and then the compound inequality at the very end.